Is it recording? Okay, so here are your A, B, C, and D values. So the first thing you do is you draw like a visual. So here I drew like two triangles representing the angles that I chose. So this would be like, for example, 60 degrees. This would be the 30-degree pair of triangles. Yes, question?
What skill are you trying to do?
Skill 7. Yeah.
That's just a number to me. I don't know it.
Oh, skill 7 is solving trigonometric equations using trig identities. Yeah. And so you know this length and this length based on the coordinate on the unit circle. So for example, this would be root 3 over 2, and this would be 1/2. And then for this set of triangles, this would be root 3 over 2 here, and then 1/2 over here. Any questions so far? Nope? Okay, so for this triangle, I wanted to find the sine of x equals 1/2, and then for this triangle, I use tangent of x is equal to plus or minus root 3. Question? Okay, like you could have used anything here. So if you wanted to do cosine of x, you could have done cosine of x equals root 3 over 2. Or for this one, you could have done cosine of x equals 1/2. But here I just chose sine of x, I said what it was equal to, and tangent of x. And this is plus or minus 3 is because of these two triangles. Any questions so far? You're getting the board? Okay. So now, the equation that you get out of this would be sine of x minus 1/2 times the tangent of x plus root 3.
So this could also be 5 pi.
Do you have a question on where I got this from? Are you even taking a video? Okay. So this is like essentially the same approach to when you solve a quadratic problem, like a quadratic equation problem. So like this would give you the solution when it's equal to 0 of 1/2. This would give you negative root 3, and this would give you positive root 3 when they're set to 0. So now you have to use the trig identities when you're creating your equation. So for this, I just multiplied these two for it to be easier to manipulate. And I did tan squared x minus root 3 over here, and then this would be sine of x minus 1/2. And that would be equal to 0. So now from here I have to use 3 trig identities to create an equation. So now the first trig identity I used would be the sine of x is equal to the cosine of pi over 2 minus x. So essentially I found where the sine of x is in my equation and I substituted it with this. So that would be like one example of using a trig identity. So when you implement this identity into this equation, you'd get cosine of pi over 2 minus x minus 1/2. And then you multiply this with, of course, the tan squared x minus root 3 equals 0. So now another trig identity you would use would be the Pythagorean trig identity. And this is part of the requirements. You do sine squared x plus cosine squared x equals 1. Now, I didn't have a 1 in this problem, so what I did was, oh, by the way, this is supposed to be 3, not like 3, I don't know why I did that. Because you're multiplying root 3 times root 3, you get 3. So how I thought of this 3 would be 3 times 1. Does that make sense? Yes? Okay. So essentially, I put in the sine squared plus cosine squared x, so I substituted that in for 1. So then it became...
The domain's not going to be that.
And then I distributed the negative 3 to both the sine squared x and the cosine squared x. So then this brought me to the equation of cosine of pi over 2 minus x. And then here you would have your minus 3 sine squared x minus 3 cosine squared x.
Okay. Check out for 7.
And that equals 0. So right now you've used 2 identities. So the third identity I used would be cosine of 2x is equal to 2 cosine squared x plus 1. Now since I didn't have a cosine of squared 2x, but I did have a cosine squared x, I sort of manipulated this identity and I got cosine squared x is equal to cosine of 2x plus 1 over 2, and this is actually one of the half angle identities. So I substituted where cosine squared x would be, I substituted this in for cosine squared x, and so then I would get my final equation of cosine pi over 2 minus x minus 1/2, right? And then multiplied by tan squared x minus 3 sine squared x. And then instead of the negative 3 cosine squared x, it would be minus 3 times this over here, which is the cosine of 2x plus 1 over 2 is equal to 0. So that would be your final equation. So that's kind of like working backwards. So you're using different trig identities to create this really big complicated equation. So now you have to find all the solutions of that, and then you would end up getting the solution set of this, which is essentially these two. So now the way you work backwards is that you set each one of these brackets equal to 0. So it's like a similar approach that you would take when you're solving a quadratic equation problem. So if this entire thing is multiplied by this entire thing, it would have to equal 0. So you set this equal to 0, and you set this equal to 0. And then when you do that, again, you plug in different identities for it, and then you simplify it even further until you get tan of x equals plus or minus root 3, and sine of x equals 1/2. Any questions? No? Great. That's skill 7. Ta-da!